talking about logs. Now let's talk about one of the really important ideas about logs that we need to understand. And this is really the whole key to solving equations with logs in them. So if you think back to the previous lecture, we talked about oftentimes have exponential functions, and the way we go about solving them is to use logs. So as it turns out, what we're going to learn now, which is very important, is that if you're given an exponential function, say so here's an exponential function, or I could even call it an exponential equation. I can rewrite. I'm not actually changing the value, changing the meaning. It's just going to look different. I can rewrite this, and I can actually rewrite this, and when I rewrite it, it's going to be in the form of a log function or a log equation. And what it's going to be is now, of course, this won't make any sense at all, but 2 to the x equals 5 is the same exact equation as x equals log base 2 of 5. As a matter of fact, here's a little, sort of like a formula that is in your book and that oftentimes people teach. And in a minute I'm going to explain. I don't really make you learn this. I used to, but I've come up with what I think is a better way. In other words, here is sort of standard log equation. Y equals log base a of x. That's a log equation. However, I can rewrite this as an exponential equation. And if I do, it's a to the y equals x. So what I used to teach, I used to say if you were given a log equation and you want to rewrite it as an exponential equation, just figure out your y, your a, and your x and rewrite it. Or if you were given an exponential equation, figure out your a, your y, your x, and rearrange it over here. I don't do that anymore because to me that became more like sort of just learning, memorizing equations and learning rules. Instead, what I'm going to show you now is the way I like to go back and forth between log and exponential equations. Now let me take a minute before we do that just to point out or to explain to you this is important because later on you're going to see you'll be given an equation with log terms. I mean, you may have here's an equation with 2 log terms. You're asked to solve it. One of the things we're going to eventually do when we solve this equation, we're going to have to take our logs and convert them to an exponential equation. So oftentimes, if you're given a log equation and you want to solve it, the only way you can do it is to take that log equation and you rewrite it or turn it into an exponential equation. And once you do that, you're able to solve it. And in the same way, we'll be given an exponential equation, and we actually already have shown you this. One of the very first things I did, I said, here's this exponential equation, and I'm asked to solve it. If you look back at your notes, the way we solved this, in effect, was we turned this into a log equation. So that's why it's so important to be able to understand how to go back and forth between a log equation and an exponential equation. So that is, if you're given an exponential equation, you need to know how to rewrite it as a log equation. Other times, you're given a log equation and you need to rewrite it as an exponential equation. And that's why in the homework and on your quiz and even on the test, you will have problems where the problem simply is, here's an exponential equation, rewrite it as a log equation. And then you'll have some problems where they'll say, here's a log equation, rewrite it as an exponential equation. And the reason they have you do that is because later on, when you begin to solve problems, solve equations, you have to be able to go back and forth between log equations and exponential equations. So now, instead of memorizing sort of these little equations and figuring out your A's and your X's and your Y's, I like to do it in a more practical sense where you just sort of follow some steps that are easy to remember and you can accomplish the same goal. So for instance, as an example, here's an exponential equation, and I'm asked to rewrite this as a log equation. Now you could, and maybe some of you already learned this in math, where you just use these two, okay, fine, go ahead. I actually have a way that I think is easier for me, at least, to understand, and maybe will be for you. So here's a little method to convert this from an exponential equation to a log equation. What I'm going to do is, I'm going to take the log of both sides of this equation. Now here is the key point. I'm going to take the log, but in this case, because my base is 2, when I take the log of both sides of the equation, I want to make the base of my log to be the same as the base of my exponent. So it's almost like the steps are, take log of both sides, and then important note, I'll just write here, make sure you have the correct base of your log. And it's not hard, it's just the base of your log needs to be the same as the base of your original exponent. Why is that important? All right, now here's a rule about logs which you need to know. There are a few rules about logs which you need to learn because you just have to know them and use them. Here's the first one. Anytime you have log base a, and inside the log is a to the x, so the key is the base of your log is the same as the base of the exponent. When you have this situation, this whole thing simply equals the exponent. So for example, log base 5 of 5 to the third. So I'm taking the log of an exponent, and the base of my log is the same as the base of my exponent. That whole thing equals 3. Just to try and confuse you a little bit, what if I had the natural log of e squared? What's the base of a natural log? Just to make it so obvious, right? Natural log really means log base e. So what do I have here? The base of my log is the same as the base of the exponent. Therefore, it would just be 2. Just to see if you're getting this, how about log base 4 of 5 squared? Well, that's an example of where I'm sort of stuck because the base of my log is not the same as the base of my exponent. So I don't know what this is. However, if it was log base 4 of 4 squared, now the base of my log and the base of my exponent are the same, and it's 2. So that's a very important rule about logs. So that's why when I came up here, when I took the log of both sides, I wanted to make sure that the base of my log was the same as the base of this exponent. So now this whole thing, log base 2 of 2 to the x, it's just x. So let me remind you, what I started with was 2 to the x equals 5. That's what I started with, and I said that's an exponential function. Please rewrite that as a log function. And then I took the log of both sides, and next thing you know, here it is as a log function. Do another example just very quickly without all the explaining and all the messiness. So let's just say here's an exponential equation. Please rewrite this as a log equation. What do? I'm going to take the log of both sides, and when I do it, since the base of my exponent is a 7, it's going to be log base 7. Log base 7 of 72x is just 2x. So now this exponential equation rewritten as a log equation is this. So in the homework and on the quiz, that's what they'll ask you to do. They give you an exponential equation, and they say, matter of fact, if I look in the book, I'll just throw a couple out here. Here's one. They say, instructions are Change each exponential statement to an equivalent statement involving a logarithm. So basically saying change the exponent into a log. We'll take the log of both sides. Although in this case, what's the base of my exponent? It's a, so I'm going to take log base a of both sides, log base a of a squared. So a squared equals 1/6 is the same as saying 2 equals log base a of 1.6. Let's do a natural log just for fun. Oh, let's do this one first. This one might be a little confusing. Let's start out, make sure everybody is getting this. E to the x equals 8. I'm asked to rewrite this as a log function. I'm going to take the log of both sides. What's the base of my log going to be? Has to be base e, which is actually natural log. So I'm going to take the natural log of both sides of the equation. Natural log of e to the x, I can think of this as log base e of e to the x. There we go. This one here is a little tricky because they stick in a variable in here. E to the 2.2 equals m. If we want to rewrite that as a log equation, the whole key is what's the base of my exponent. That determines what kind of log I take on both sides. In this case, I want to take natural log. So 2.2 equals natural log of m. All right, hopefully not too hard, right? So that's an example, those are all examples. Given an exponential equation, how to find the equivalent log equation. Now let's go the other way around. What if you're given a log equation and they ask you to rewrite it as an exponential equation? All right, this is also something I came across a few years ago that I thought made this very simple. So let's say we had log base 2 of 100 equals x. I want to take this log equation and rewrite it as an exponential equation. Now this I call the circle method, because it's almost like what you're going to do is sort of make like a circle when you look at this log equation. What you do, you always start with the base of the log. And what you do is, from the base of the log, you go to the other side of the equation. And this right here translates into, here's your base. You move to the other side. The other side ends up being the exponent. So you start with the base, write your base, move to the other side of the equal sign. And then, this is where the circle idea comes. Then you go back to the original side. And I'm actually going to go back to the inside of my log equals the inside of the log. Log base 2 of 100 equals x. can be written as 2 to the x equals 100. Here's a log equation. Let's rewrite that as an exponential equation. Start with the base of your log. You go to the other side, in this case 2 cubed. Then you come back and grab what's inside the log, equals 8. Very straightforward. How about log base A of 3 equals 6? I want to rewrite that as a exponential equation. A to the 6th equals 3. It's as simple as that. Now, how does that play itself out in practical problems? Well, here's an example. In the homework, what they're eventually going to do is they're going to give you a bunch of log expressions, and they want you to calculate the exact value. In other words, I'm looking at the book, some of the homework problems out of the book. They're basically saying, what is log base 2 of 1? Since they're asking for exact values, they don't want you to go and grab your calculator. They don't want some kind of decimal number. They want you to just figure this out without using your calculator. And what I always do is I sort of rewrite this, since I'm trying to see what this equals. I sort of rewrite it and I call it x. So it's like I'm trying to figure out what x equals. Instead of the question mark, I put an x there. And the reason I put an x there is the way I'm going to solve, this is like now a log equation. And I told you a while ago that oftentimes if you have a log equation, the way we're going to solve a log equation is to convert it to an exponent. And that's what I'm going to do. The rule I just learned, the little circle method, I'm going to apply it to this. 2 to the x equals 1. And now I ask myself, all right, what does x have to be? 2 to what exponent equals 1? And hopefully you remember an exponent of 0 always makes it 1. So we would say log base 2 of 1 equals 0. Here's another example from the book. Now some of these you might already know because we've learned some of these rules, but let's go ahead and use a circle method. So I'll call this x. 8 to the x equals 8. Obviously, what does x have to be? 1. Here's why I said some of you might have known this already. You know what this is? If you think of an exponent of 1, this actually goes back to our special rule we learned. Log base 8 of 8 to the first. Remember what happens? Those cancel out. Let's do a few more. Log base 5 of 25. What does that equal? call this x. Let's convert this into an exponential equation. 5 to the x equals 25. Hopefully, right away you say to yourself, oh, x has to be 2. Log base 5 of 25 equals 2. So that's all there is to it. In the homework, they're going to give you some log expressions, and they want you to, let's see if we get something a little trickier. How about, here's one looks interesting. Wow. Log base 1/2. First time we've seen that, where the base is like a fraction. Log base 1/2 equals 16. Well, let's convert this into an exponential equation. See if we can figure it out. One half to the x equals 16. That looks a little tricky. So here's one that I've converted it into exponential equation. Now it's almost like this is like a trick question where you know what I'm going to do? I don't expect maybe you to know this necessarily, because this is like a trick question. I just chose one from the book. I'm going to flip this fraction inside. I can do that, but I have to make my exponent a negative. This is probably a bad example to do, but anyways, so now I can rewrite this as 2 to the negative x. You know what 16 is? 16 is 2 to the 4th. So as it turns out, x equals -4. All right, that was sort of a trick question. Getting to here is very simple, but then figuring out what to do later on is sort of a pain. But the good thing is most of the time you will have problems like this and it will not be that hard to do. Let me show you this one, because sometimes we have these kinds of problems where normally when you're doing math, when you have square roots like this, a lot of times you want to change square roots into rational exponents. So I'm going to rewrite this. Square root of e is the same thing as e to the 1/2, right? Now here there's two ways to do this. I could convert this to an exponent, which I'm going to do, and you know what? Natural log here, what's my base here? It's really e, right? E to the x equals e to the 1/2. Obviously x is 1/2. Now you could have realized from the start, natural log of e to the 1/2, I've got the same base on my log as inside the base of my exponent, so right away you know it's 1/2. But it's very important to be able to use this circle method to convert log equations into exponents. All right, so now you should be able to go ahead and start start solving some of these equations. So for instance, let's do a few more. I turn the page to some more homework problems. We're asked to solve this equation. In other words, what does x equal? This is a log equation. I'm going to say it over and over again. Most of the time, in order to solve a log equation, you need to convert the log equation into an exponential equation. That's the way you solve log equations. You convert them into an exponential equation. So here, the circle method says x squared equals 4. Now you can look at that and say, well, what do you have to square to equal 4? 2. We solved the equation. How about here's one. Log base 3 of 3x minus 2 equals 2. We're going to solve this equation for x. Whenever you want to solve a log equation, convert it into an exponential equation. Circle method. 3 squared equals this whole thing, whatever's inside the log. 3 squared is 9. Ends up being a pretty easy equation to solve. Add 2 to both sides. Divide both sides by 3. There's your solution. I don't know how in the world you could solve this equation without converting it into an exponent. But once we convert the log equation into an exponential equation, it's an easy problem. Let me see if there's another one maybe we can do. Now in the same way, here's an exponential equation, and they want to solve for x. The way we solve exponential equations most of the time is to convert it into a log equation. So I'm going to take the log of both sides. What should the base of my log be? It should be log base e, which is natural log. Natural log of e to 3x. Remember, the base of my log is the same as the base of my exponent, so it's just 3x equals natural log of 10. And here they ask for an exact answer. So they don't want a decimal here, they just want to leave it like this. But this is a number, natural log of 10 over 3. How about I'm going to make a problem up here. Now here's where it gets sort of tricky, because I want to convert this into a log equation in order to solve it. Now there's really two ways I can go about doing this. The first way is I can take the log base 4 of both sides, right? That's how we convert exponential equations into log equations. So this becomes x plus 1 equals log base 4 of 2. I would have this. The very tricky thing about this is if they actually ask me to calculate it, I can't use my calculator. So sometimes what people will do, matter of fact, when they give you the problem like this, they'll say solve for x, but they'll say, but write the answer with log base 10, common log. Now when they specifically ask for log base 10, then I can't take log base 4 both sides, because look at my answer, it's got log base 4. I need to have log base 10. So what can I do? Well, here's what you can do. I can actually take log base 10 of both sides, because now I remember that special rule that when you take the log of an exponent, you can bring the exponent in front. So if I'm going to solve for x, let's divide both sides by log 4. Please do not ever think log 2 over log 4, like these reduce or cancel. Let me over here, say someone decided, oh, you know, this is like 1 over 2. No. You can't go inside of a log and cancel out something else with another log. Instead, the answer simply is just going to be log 2 over log 4 minus 1. Looks a little messy, but that's the answer. So let me wrap this up by doing a couple more problems. So really, sometimes you have a choice. Let's keep it simple. Say you were given this. Let's make it something more interesting. How about 7 to the x equals 13? And you're asked to solve for x. The way I'm going to solve for x is I'm going to use logs. Two possibilities, and I should get the same answer either way. If I want to just think to myself, let's convert this into a log equation, then I'm going to take the log base 7 of both sides of this equation. Because log base 7 of 7x equals x. Now I've solved it. However, in this case, they actually want the answer. They want an actual decimal number. So I cannot go to my calculator and right away calculate this. However, I can do change of base. If I convert this to base 10, it'll be common log of 13. Right? Change of base. If you need to go back, look at your notes. This is why change of base comes in handy. So now I can go grab my calculator. Log base 10 of 13 divided by log base 10 of 7. So that's one way. So once again, to review, this is the way where I decided to take this exponential equation, convert it to a log equation, take the log of both sides. However, I can do the same thing here. I can take the log of both sides, but instead I'm going to take log base 10 of both sides. Now the advantage of this is at least I'm using common logs when I eventually grab my calculator, but the problem isn't always as simple at first, because now I have log of 7 to the x equals log of 13, but then I remember that special rule. I can move the x out front. And now if I want to solve for x, and actually, you know what? If I look over here, I get the same thing. For me, normally, if I see this problem and I have a choice, to me, this over here appears a little bit easier. A lot of times, if I'm solving an exponential equation like this, I'll just take log base 10 of both sides. I could take the log base 7 of both sides, but then the extra step is I have to use change of base. But either way is perfectly fine. All right, so we will stop there, and then on the next video we'll cover some other topics that we need to understand concerning logs.